So in this video, we're going to talk about an abbreviated version of Gauss-Jordan, and I'll get to what I mean by abbreviated in a little bit. So the first thing I want to remind you as we look at this augmented matrix is that the columns represent, the first column is represented by x, the second column is y, the last column, or the third column is z, and the last column is equal to. The last column is always equal to. In some textbooks, you might see the first column referred to as x1, x2, and x3. That's only because the need might grow sometime. We're never going to do it by hand, but you can see that a computer program might need a matrix to be much bigger than 26 by 26. You might need more than, there's 26 letters in the alphabet, and you might need more character or more elements than 26 characters. So that's the only reason for the difference, but I'm going to use x, y, and z in this example. So hopefully, so I just want to review how to read this off. I want to make sure you understand where this all comes from. So if you can see here, as we look at this, there are no x's, on this last line, there are no x's and no y values. So that can you see that z equals 4? That's exactly what this means. You need to be able to read this and go, oh, well, there's only one z, and that z happens to equal 4. So we would say z equals 4. On the second line, there are no x's and there are no z's, but there's one y. So that would simply mean y equals -2. So y equals -2. And on the top line, you can see that x equals +3. So the solution to this is very nice. It's just 3, -2, 4. That should have been a soft bracket. So what I want you to notice is that here on the principal diagonal, I have all ones, and everything else, so I'm going to circle those in orange, everything else are all zeros, okay? So if you can get all zeros in those two triangles, notice they're kind of like two triangles, and then you can get your diagonal, your principal diagonal to be all the number ones, then it's very quick and very easy to read off your answers to this problem. But we're going to talk about one where it does not start out like that. So looking at this augmented matrix, let's see if we can evaluate what x, y, and z are. So as I look at this, it's important that you be able to read this. Can you see that on this last row, I have no x's and no y's. All I have are z's. So I could just straightforward solve for that. I have 4z equals 4. So z has to equal -1, which is great, right? So now I'm going to take that -1 and for z, and I can plug it into that second equation, because in the second equation, which is nice, I don't have any x's, but I have y's and z's. So as I write that equation, I have 3y minus 2, and then we just solve for z, which is -1, equals 5. So I have 3y plus 2 equals 5, or 3y equals 3, or y equals 1. Okay, so we've solved for y and we've solved for z, and now I can take both of them, right, and plug it into the original equation. So I have just 1x plus 2y, so what is my y value? Well, that was 1, plus 4, and my z value, which was -1, equals 6. So I have, x plus 2 plus -4 equals 6, or x minus 2 equals 6, or x equals 8. So it was pretty easy, right? It wasn't, it was nicer when we had that matrix with all the ones and zeros in it, but this wasn't so bad, right? This only took me, 30 seconds probably to show you guys, to come up with my x, y, and z. My x was 8, my y is 1, and my z is -1, and that's the final answer. But what I really want to point out here is, so instead of a matrix with all ones and zeros, all I had to do this little work was I had zeros in my lower left corner. So notice the lower left corner, if there's only 3 rows, which is primarily what we're going to be working with, you need the second row to begin with a 0, and in the third row you need 2 zeros, okay? So if you can just get those all to be zeros, then it only takes a minute or two, I think, to solve the rest of this. So we're going to talk about that next. So let's look at one more example. So what I'm going to do is, here's a new matrix, and what I want, augmented matrix, and what I want to do is I want to focus on getting this triangle only to be 0. So that just that triangle right there, the lower left triangle, I need all those three numbers, those three elements to be 0. So what I want to do is I always want to work from the top and over to the right. So I'm going to focus on this first to make it 0, and then I'll go to those two. So how do I get this guy to be 0? And this is going to be using our row operations. So if I multiply the top row by 3, if I take this top row and multiply it, by -3, and then add it to this row, can you see that that's going to turn into 0? Because -3 plus 3 is 0. So all I'm going to do is I'm going to, let me do this on the right. So what I'm going to do is I am going to multiply -3 times row 1 and add it to row 2. So that's the operation that I'm choosing to do. So this scalar multiple, this -3, what I'm going to do is I'm just going to write them up above. So if I multiply that by -3, I'm going to get -3, -6, oops, that's negative, -9, and -6. So now I just write those there to help me. It's just a visual aid. I'm really not changing the first row. All I'm doing is I'm just writing those in maybe pencil or something to help me remind me what they are so that it's easier to add. So the first row actually did not change. So the first row is going to be 1, 2, 3, 2. The second row now is going to be when I add the two together. So I'm going to get 0, which is what I wanted, right? -11, -13, it's negative, and not +9. These are both negative, okay? And the last row did not change at all, so I still have -2, -3, 2, and 2. So we're a third of the way done. We got this first value to be 0, which is awesome. So now we're going to focus on this -2. You can only focus on one thing at a time, generally. Sometimes it works out that two things work out, but so let's turn this into a 0. So if I multiply this first row by a a +2, and then add it to that, that will turn into 0, right? Because 2 plus -2 is 0. So that operation is going to be to multiply the first row, so row 1 by +2, and I'm going to add it to row 3. So if I do that, I like to take my scalar. Whenever I'm multiplying by a scalar, I like to just write it up top a little, right next to the numbers. So I'm going to get 2, 4, 6, and 4. So I'm going to add those. So my first two rows actually don't change. So 1, 2, 3, and 2. And then I have 0, -11, -13, and 9. But when I add these other two rows, right, I'm adding this little number I wrote plus the last row. I'm going to get 0, which is what I wanted. And then I get 1, 8, and, oh, that's a +4, sorry. So that is going to be 6. Sorry, that didn't look like a 4 there. Okay, so that's a 4. All right, so we're almost there. We're 2/3 of the way there. So these two are 0. So now how do I turn this one into a 0? So I'm going to have to, if I'm going to add this to something else, I'm going to have to multiply. I'm going to have to focus on the second row. So another thing I can do is I can always multiply a row by a scalar. That's another valid thing to do. So what if I just take my row 3 and I'm going to multiply it by just 11? So I'm just going to multiply everything in that third row by 11. So my first two rows stay the same. 0, -1, -13, and 9. And then on the bottom I'm going to get 0, 11, 88, and 66. So now, as you can see, I can add these two, right? So now if I just simply add them, so I'm going to take row 2 plus row 3 and add the 2, then I get, I'm going to get, my first two rows are not changing, 0, -11, -13, and 9, and my last row, when I add the two together, I'm going to get 0, 0, and then I get 75, and another 75. So what I wanted was, I wanted this bottom triangle to be all zeros, and it is. So because now, hopefully you can see that Z is because just like I did at the beginning of this video, I'm going to get 75z equals 75, so z equals positive 1, and then I can take that value and I can plug it back into the second line for z, or excuse me, for y, and if I'm not going to take the time to do that, but if you want to try it out, your answer should be, your x value is going to end up being 3, your y value is negative 2, and your z value is positive 1. And that's the final answer. I'm just not going to take the time to go through all that substitution there. But, so the difference here between the abbreviated version and the full version of Gauss-Jordan is that I'm just focusing on getting these last 3 zeros, or excuse me, this little corner to be all zeros. If you want to do the full version of Gauss-Jordan, then what you need to do is you need to focus on getting this diagonal to all be 1s and everything else to be zeros. So all of these row operations that we just did, I think they're a little more time consuming. I think they take a lot more thought. There's a lot more room for error in coming up with these. So the abbreviated version that I do is I just I just focus on getting this bottom corner to be zeros, because then I can just very straightforward, with a few steps, solve for x, y, and z. You remember you have to go backwards, you have to start at the bottom and go up. So, but all means, if you want to do the full version of Gordon or Gauss-Jordan, that's totally fine. If you like doing this row operation and you want to keep going, just then keep doing it that way. Otherwise, this is whichever version you want to do is fine with me.